All right, so here is the second problem on the 2D forces review. I am being helped by my son, Elias. Say hi.
Hi.
And it's a little bit before 6 in the morning, and he's up early, so he's going to help. Also, my computer is dying here, so we're getting one chance at this. And so we're going to do this as quickly as we can. So if it looks like I'm going fast, it's because my battery is dying. All right, so what we're going to start off with here is we're going to draw a quick sketch. All right.
Okay.
And the sketch will look kind of like this, and then we'll have a force of friction going this way.
Okay.
Thanks, buddy. And it's 20 newtons. All right. We do know the coefficient of friction is 0.33. Force of friction is 20 newtons. The net force is 15 newtons. I know that's kind of weird for me to give you a net force, not anything else, but that's what this is the way we're going to do it. Now, with what we've got right here, your first step on these problems are always find force perpendicular and forced parallel, right? Because force perpendicular is the normal force.
Okay.
And the parallel force is F pull.
Okay.
Now, I've given it to you in a way where you can find them, but you have to do some work first. So we're going to start by finding F norm, because that's going to be the earliest.
Okay.
FF equals F norm times mu.
Okay.
Now, FF is 20. F norm we don't know.
Why are you talking on your computer?
I'm making a video, buddy, so they can hear you right now.
Oh.
And, geez Louise, this is not, did not draw very well, so let's try that again. 0.333. Okay, for whatever reason, it's not wanting to come out very well. The F norm then will come out to be, it should be 60. But I'm going to just double check my math real quick. Yeah, it comes out to be 60 newtons. So that means that this is 60 newtons. Now, the next thing I give you is that F net is 15.
Daddy?
All right. The 15, all right, is how we're going to find F pull. Now, you might be thinking, well, I can just use F net equals ma. However, that's not going to be very useful because we don't know the acceleration. We don't know the mass. It's not really going to give us much of anything. So what we're going to use, though, is we're going to use this F net. And for whatever reason, is not the time for my pen not to work. But my pen is not working. I'm going to try a different size. See if this helps. So F net will be equal to the sum of all the forces, which will be F pull plus F friction. Now, remember, this way is going to be positive. This way is going to be negative. So, with what we've got, F net should be negative, all right, and F pull should be negative. So this will be a negative 15. F pull, we don't know yet. Sorry, my pen does not want to work. Plus force of friction, which we know is 20, and that's up the incline. And so if we solve this real quick, we get F pull is equal to negative 35 newtons. Okay, so this will be 35 newtons. Now from here, all you have to do is run through any of the three strategies that I have already given you, okay? Because now you have both components. You can do solve for m and substitute. You can do the Pythagorean theorem, or you can straight up just do divide and conquer. I'm going to do divide and conquer because it's the quickest, and in the interest of battery, I'm running out. So we know that tangent theta is equal to opposite over opposite over, that's not hypotenuse. Race. It should be opposite over adjacent. In this case, that is tangent theta is equal to 35 over 60. So if I inverse tangent that real quick, I can get my angle. And so that's what I'm going to do. I'm just going to inverse tangent 35 divided by 60. And I get 30.3 degrees. So 30.3 degrees is theta. Now, I know that my F perpendicular is 60 newtons.
Okay.
So this is 60 newtons, and that is equal to mg cosine of theta. And I also know what my angle is now, so I should be able to figure this out. So 60 newtons is equal to the mass times 9.8 times the cosine of 30.3. You get 0.864 for that. And so if we solve for the mass here, we get 7.09. So the mass ends up being 7.09 kilograms. And so there are our answers. Now, to recap, first thing, find your components, F norm and F pole. Label those. As soon as you have those, then you can use one of those three strategies I gave you with the Incline Plane Lab. I used divide and conquer because, like I said, battery was running out and needed to finish. So here you go. This will be uploaded shortly. Say goodbye, Elias.
Goodbye.